All right, hey, I wanted to get this video out to you guys. If you had some questions on the worksheet before you turned it in, it is not due tonight until 10 p.m. I wanted to thank each of you who have taken the time to fill out the survey that I sent to you, just asking how you felt things were going. And I really appreciate all the feedback that you guys are giving me, because I'm just trying to make this go as smoothly as possible and take into consideration that you have other classes that you have things to do for. So here were some of the top questions. I'm going to look at number 8 with you. This again is something that we've had on the last several worksheets. They start out by giving you a right triangle, but they're not giving you one of the sides. This is where I am asking that you guys please show the Pythagorean theorem. And so it looks like we're missing one of the legs for this. And so you would want to, this is the part I'm asking that you show. If you want to do the rest of it on your calculator, not a problem at all. Okay. Oh, I wonder if oops, I have this labeled wrong. I'm sorry. It looks like, no, that's right. Okay, my bad. Okay, so I'd ask that you show this first. Then, of course, you know, if you wanted to do the rest on your calculator, entirely fine here. I'm just going to work this out. So we do the Pythagorean theorem. We end up getting that missing leg is the square root of 57. Okay, and then past that, all you guys are doing is you're just going to set up the 6 fractions. You do have to take note, though, that the angle where the theta symbol is, that has to be your focal point. Okay, so for some of you, it might be helpful then that you go the extra step and you just label that the side 8 is the opposite, that the side square root of 57 that we just found there is the adjacent, and of course, the side that's labeled 11 would be the hypotenuse. Okay, past that, you're just going to set up your 6 fractions. We're doing opposite over hypotenuse for sine. Remember, the reciprocal fraction to sine is cosecant, and so I'm going to jump down there. I'm going to go ahead and do the reciprocal for that. Okay, and then I'm going to do cosine, that's adjacent over hypotenuse. Okay, and its reciprocal partner here for cosine is secant. Okay, so we're going to flip that. Okay, and then lastly, tangent is opposite over adjacent, and we know that its reciprocal partner is obviously cotangent, and so we're going to flip that. Okay. All right, so that's how you do number 8. Lots of questions that you guys had actually on 9 through 12. I think the key here with 9 through 12 is you have to look, the directions are asking you for the arc length, okay, which in and of itself is a pretty simple formula. I think where you have to be careful is you have to look at what the formula wants. It is always using the radius. It never ever uses the diameter. So if in a problem like 10 and 11, you can see you're given the diameter, immediately you need to determine, well, what is the radius? So I'm going to start with number 10 here. The diameter is 22 feet. So that means we immediately need to say, okay, well, the radius is going to be half that. That's going to be 11 feet. I'm going to go ahead and jump down here to example problem 11. That means that the radius would be 3.5 inches if the diameter were 7 inches. Okay, that has to be the piece of information you're using when you plug it into the formula. The other really crucial piece is you're going to plug the angle in here for theta, but it cannot be the angle in degrees. It must be the angle in radians. And so if you look at number 10, you can see they're giving you the angle though in degrees. And so we have to look back at that previous notes page that showed us how do we convert out of degrees and into radians. Well, that's when you multiply by pi over 180. So I'm going to multiply by pi over 180. Now remember, technically on the calculator, you're going to type in 330 divided by 180. Then you're going to have the calculator switch that back into a fraction, and you should see on the calculator that comes out to 11/6. But then you have to attach that pi symbol back onto the answer. This right here, 11 pi over 6, that is your central angle, but expressed in radians, because that's what the angle, or I'm sorry, the formula is asking for. Okay, so now I'm good to go here. I'm going to use my formula. I'm going to plug 11 in for the radius, and then 11 pi over 6 in for the angle, and you're just going to type that into the calculator. At this point, you should type the pi symbol into the calculator here when you're doing this calculation, and that's how I would get 63.36. This is going to be labeled feet because that's how the diameter and the radius are measured in. Okay, so that's how that works. Okay, if you look down here in this next example, you can see we already switched it into the radius, and 11 is a little bit easier because I don't see a degree symbol. In fact, when you see the pi symbol, that's kind of a clue that the angle is already in radians for you. Okay, so this one was a little bit easier because when we go to use our formula, we got to make sure we're plugging in not the 7 for the diameter, but the 3.5 for the radius. And then I can go ahead and just directly plug 7 pi over 6 in for the angle in radians. Again, you're going to type this all into your calculator, even the pi symbol, and this is going to give you an answer for number 11 to be 12.83, and that should be labeled inches because that problem, it was giving you the diameter in inches. Okay. Hopefully this is making sense. You're seeing how this works. Even if you were struggling with number 9, you can go back and see that number 9, thankfully they gave you the radius, so that's good. But on number 9, you can see the angle is in degrees, so it's going to be on you to change that from degrees into radians. So let's look at one more, number 12. Okay, the good news is they already give us the radius. The bad news is the angle is in degrees, not in radians, so we do have to convert out of degrees and into radians. Again, same thing on the calculator. You're going to take 240, divide it by 180. This is not cross multiplying, folks, okay? Cross multiplying is when you have two fractions that are equal to each other. This is a fraction times a fraction. So you should be typing in 240 divided by 180, switch that back into a fraction. You should see 4/3, and then again, you want to reattach the pi symbol here onto your answer. Okay, we're going to use our formula for arc length. Substitute 6 in for the radius. 4 pi over 3 goes in for our angle. Again, that all gets typed into the calculator. And here we go. The answer for number 12 would be 25.13 centimeters. Okay, lots of questions on 19 and 20. Again, I will draw your attention, and maybe you missed this. You have to look at the directions in bold above both 19 and 20. You'll see it gives you a really vital piece of information you need, which is in both of these problems, the altitude that the pilot is flying at is 5.5 miles. Okay, so in both of these pictures, I'm going to label this vertical distance here, that's what altitude is, as 5.5 miles. Okay, now if you read through number 19, it goes on to say that if the pilot begins descending 200, keyword here, horizontal miles from the airport, okay? So let's say right here's the airport, okay? 200 horizontal miles. Okay, that's not the hypotenuse, that's this distance right here. Okay, so you're going to label that as 200 miles. The question is, what angle with the plane's path would be made with the runway without any further adjustment? Okay, so again, all these problems, they're talking about angles of depression and angles of elevation, and we said that's always the angle down here in the bottom right of your triangle, okay, which again technically is that angle up here. Okay, so if I'm going to set this one up, I'm going to say, okay, well, I know the opposite side is 5.5. I know the adjacent side is 200. That's telling me I should definitely be using tangent in this scenario. I'm going to set it up like this, and then I need to show, okay, what am I actually typing into the calculator? Well, I'm actually going to type in this, inverse tangent of 5.5 divided by 200. Okay, you have to be in degree mode. We're going to carry these angles out to one decimal place. Should be 1.6 degrees. Okay, moving on to number 20. Okay, you'll notice I also labeled that 5.5 miles there. Only this one is worded in such a way that it says, for the comfort of the passengers, the maximum angle of depression on landing is 5 degrees. Okay, so they should only be tilting the nose of the plane down 5 degrees. Any more than that, it's going to feel like the plane's taken a nosedive. So technically that 5 degrees is this angle down here. Okay, the question is, at an altitude of 5.5 miles, which they repeated that again even though that was given up here in the problem, what is the minimum distance? And look at what's in parentheses there, guys. It says measured on the ground. So they want this distance here, measured along the ground, that the pilot should begin his descent towards the airport. So I'm going to label, again, we're using this angle in here. I know the opposite leg is 5.5. What I'm looking for is I'm looking for the adjacent leg. So this is another tangent problem. Okay, only this time I know the angle is 5 degrees. I don't know that adjacent leg. Okay, so here is where we would go ahead and cross multiply. Okay, because I've got two fractions equal to each other. And then we would divide both sides by tangent of 5 degrees. Again, if you're in degree mode, you would type in 5.5 divided by tangent of 5 degrees, and it would tell you that the pilot, when he's 67.87 miles back away from the airport, that's when he should start tilting the nose of the plane down to make it there on time. Hopefully this video helped. You guys, again, always feel free to reach out if you guys have any other questions. All right.